All right, hello and welcome. Today is Tuesday, May 12th. May 12th. And I'm sure, it's the round two of AP testing. We still have a couple of days, so we're going to maximize our time available to us. Welcome. Today is the day before, technically, as far as streams are concerned, it is the day before our test because tomorrow is Wednesday. There's no stream, and then Thursday you'll be taking your test, so no stream then as well. So we have to make the most of today. BC students in Cal BC. Well, hopefully you'll watch this in the VOD. If you have questions, you can send them my way. I usually do a Q&A sesh after my APC stream, so you can always ask during the Q&A session at like 12:15 or 12 o'clock at noon. All right, well, as promised, today we will look at the College Board platform, make sure we are as prepared as we can be to take this test on Thursday, and then if we have some time at the end, we'll go over some of the questions from the last quiz we took. All right, so without further ado, we have Bubble Guy Kadu in the stream. Let's go and pull up the platform. This website here, if you just type it in, AP2020 examdemo.collegeboard.org, this will allow you to play around with the platform. So basically, you can simulate how it's going to be on Thursday, or for Cal BC kids in an hour. So I would definitely play around with this. This will make hopefully make you familiarized with the platform, so you know the ins and outs and not surprised by errors and other things. APC kids took their test yesterday. For the most part, it went okay, but I think one or two students did have some issues, and College Board, the president of College Board, tweeted out that about 2 to 3% of students had issues, technical issues. And basically, when that happens, you open up a tech ticket and then you schedule for a makeup test that's in June, a month from now. College Board should have sent you an email. Actually, if you have tests for Monday and Tuesday or Wednesday, you should have gotten an email with a ticket. However, for you guys, for Thursday's test, sometime today, you're going to get an email from College Board giving you your ticket to take the test for Thursday. So they are sending out testing tickets 2 days prior to the exam date. So for Thursday's test, you should get it today, basically. Emma says it came this morning. Bubble Guy says, yep. So sometime today, you should expect an email from College Board giving you your ticket. And near the bottom of your email, make sure you read everything. Near the bottom, there's also a link for the tech stuff. So if you have issues today, make sure you use that link. Tell them exactly what happened. Be as descriptive as possible, and then you can, I guess, take a retake or do a redo in June. You're not supposed to take pictures of questions and stuff, so don't use your phone to take pictures of the actual questions. However, after you submit, and let's say there's an error, I would say take screenshots or take pictures of the actual errors. This will help you during the tech ticket application process. So maybe you can use that as evidence or something. So don't take pictures of the actual question, but do take pictures or screenshots of errors that may pop up on your screen. So first things first, in the email, you should have, of course, you should have your AP ID. This is something you will need. So I would definitely write it down on like a Post-it and just keep it on or your desk or wherever, your table or wherever you're taking your test, right? So write it somewhere, have that with you. For the most part, you'll be using this ID number throughout your submissions as well as your initials. So you're supposed to initial, and I'll explain that as I go through this platform. To use the demo, of course, this demo website, instead of typing in your ID, you would just write practice. So this is just for the demonstration. Again, when you actually click the link to take your test, you would type in your AP ID in here instead of the word practice. Okay, those of you who are on, your computers, your personal computers, definitely make sure your browsers are up to date. And everyone, just a general rule of thumb: clear your cache. Clear your cache. Sometimes browsers just have issues when you have too many, weird stuff or too temporary files, etc. And all of these things can mess up the browser and make it work less efficient, or potentially cause errors, potentially cause blue screens, etc. So what can you do? Number one, you can clear your cache, your temp files. If you type here, let me see if I can pull something up. So when you hit the Windows key or just start, you know how there's a search. Actually, there is no search. If you just hit the Windows key and just start typing, you'll get a search bar. So Windows key, which activates search. And then type %temp%. This will, and then hit enter. This will open up your temporary folder. This is your computer temporary folder, not for your browser. Go ahead and delete everything inside the temporary folder. This will clear everything out, and then of course when you do this, you want to restart your computer. And then for your browser, of course, you can go to your settings in your browser and then clear the temporary, your history, your cookies, and all that stuff. Clear browser, temp files, history, cookies, etc. Okay, this will be nice and clean. Make sure you restart. Yes, I started using the Edge Chromium version, which is a lot faster than Chrome, but again, Chrome is fine. I don't think the school laptops have Edge Chromium, so I don't know. Bonte, did you do copy paste, or did you do pictures when you took your test yesterday? You did paper and then you took pictures? Okay. All right. Well, so it kind of depends. It kind of depends. And I'll talk about the various methods. So let's go ahead and take a look at these platform. Hit practice if you want to practice. So boom, there it is. Once you're in, so once you type in your ID, you get to here. Then you got to type in some stuff, I suppose. Let's see. I'm just going to make some stuff up. Name. My name is Bonte. My last name is... What's my last name, Bonte? Kohanic. No, I don't want to use your actual name. I'm going to use Blumen. All right, you're Bonte Blumen. When are you born? Of course you're born January 1st, like everyone else. Everyone is born on January 1st. Let's see. You're a 16-year-old taking the AP Physics 1 test. There you go. And then of course your email address. You want to use your school email address, 010101@ecrchs.org. Type it in again, 010101 at ecrchs.org. So I'm just making some up. Where am I doing it? From home. Yes, from home. I gotta. Yes, I agree. All right. All right. Once time expires, you'll not be able to go back to that. Okay, great. So your question. Wait, what? Question 2. Wait a minute. What just happened? Did I hit? Oh my gosh. All right. Let me try this again. Clearly something. It's not supposed to go to question 2. What the heck? All right, let's try that again. Practice. Oh, maybe it's because I used the same email. I don't know. Maybe I should change my email. Let's try this again. First name Bonte, last name Blumen. Of course, I was born January 1st, like everyone else. Everyone has the same birthday. Email address. Let's try a different email address. Stop speed running the test. It's not as fun if you're just using hacks. Oh boy. Where am I taking it from? I'm taking it from home. All right. So I guess I agree because, you know, what else am I going to do? Continue. All right, finally. Okay, it worked this time. Yeah, I think it was because I used the same email as last time. That's why it messed up. Okay, so here it shows you the various types of ways to actually answer your questions. So one of the ways is to actually open up like your Microsoft Word or Google Docs, right? You have that on the side. So one window. Remember, you don't want to do anything fishy today. I'm sure they're going to use the NSA to track every single packet that is coming in through your connection, right? And then they'll report to all the future colleges you're going to apply to. So have one window open, which is the actual test based on the link that was provided within your email. Okay. The other window you should have open at least is your some sort of Microsoft Word or Google Docs if you choose to do it this method, right? So you can do the Word document method where you read the question on your browser and then type everything up in Google Docs or Microsoft Word, and then you can copy paste it later, right? So the other method, as Bante pointed out, he used his phone. So he did everything. Now AP Physics C, of course, is much more, with writing and it might be a lot easier with calculus stuff. It might be a lot easier to actually write it. So the phone approach might be easier that way. You take a picture at the end. Make sure you save as JPG or JPEG or PNG. I believe PNG also works. And then you'd have to send it to yourself and then upload it. Now remember, you get 25 minutes for the first question and then 5 minutes to figure out all the uploading stuff. And then on the second question, you get 15 minutes followed by 5 minutes to upload your stuff. Very good. If you have an iPhone, put it on compression mode. That way the file size is small enough to be uploaded. If you're using, your 100 megapixel camera and your file is like 50 gigabytes, then yeah, you're going to have issues. Don't upload to Discord on your phone. Now, technically, you can actually open up your remember, you can open up your email on your phone and then use the link. And so you'll go to the College Board, you'll take your test on your phone, and then the submit button will say take a photo, and you can actually take it directly. So you don't have to send the picture to yourself. You can just use the phone to take a picture, and then the picture will automatically upload. For each page that you use, you should definitely write down your ID and your initials at the top of each page. All right, and the other method, what is the other method? The other method is copy pasta. Okay, so uploading files like Word documents, PDFs is one method. Taking pictures with your phone is method number 2, and then actually just copy pasting from Word document is method 3, right? I think the AP1 test is going to be a lot less calculation, so a lot more writing. Perhaps the copy paste method would be the best approach, right? All right, anyway. Let's see, my test is about to start. 30 seconds. Oh no. So as I'm about to take this test, what should I have in front of me? I should have my AP ID in front of me, written somewhere on a piece of paper. I should have my calculator, just because it's a very good paperweight, right? In case the gust of wind comes through your window and it blows everything out. So a calculator handy, just to feel good about yourself. And it is accepted that it is an open notes, open book test. Therefore, I would definitely have my 3-ring binder with all my stuff ready to go. Yep. So yeah, for AP1, I would recommend copy pasta. Your exam begins. Oh wow, look, my exam begins. So when the exam starts, you'll have this gray box, and inside this gray box will be your question. Okay, you can hide the timer if you want. Hide timer. Okay, if you have a stopwatch or like your just just a watch, or if you just have a clock environment, definitely use it. You can use your phone as a stopwatch. Keep track of your time, so you have more real estate on your screen. Right. So your first question, you get 25 minutes, and it's inside this gray box. When you can actually, you don't have to wait all 25 minutes to actually attach a response or paste your response. I'm going to choose definitely the copy pasta method. I think that's the best or the easiest way, especially for written based exam that you're going to have on Thursday. I keep saying tomorrow. So let's say your first question is up. It could be some sort of anything really, any topics from kinematics all the way to a little bit of shim. All right, so what's your question? Design an experiment to, what did I say for APC? Oh yeah, design an experiment to open up a wormhole that can travel to Alpha Centauri in a matter of seconds through hyperspace. Consider the type of devices that you may need. Consider what kind of measurements or what, and create a step-by-step process for other students to follow. All right, here's my question. All right, great. So now I have 25 minutes to figure out how to open up a wormhole. So I'll go to my Microsoft Word and start typing. Step 1, pull out your Dragonite. Step 2, tell your friends to bring out their Dragonites. Step 3, have all Dragonites fire Hyperbeam at the same spot in space. All right, so all of y'all on your Dragonites, fire Hyperbeam at the same spot. This will create so much energy that it will literally tear a hole through space. This will cause a hole to open in space. And step 5, hopefully it goes to step 5 question mark. Step 6, profit. All right, so there's my response. I'm done. I still have some time. Now, if you theoretically, even if your 25 minutes is up, you could use the extra 5 minutes to finalize your answer, because you don't really need that much time to upload, theoretically. But you should try to finish up the question within 25 minutes. All right, so now that I'm ready, I'm going to say paste response. So this is the copy pasta method. When you paste response, you get this window. Now you can actually go back to the question. If you go back to the question, whatever you pasted will disappear. So make sure you take a look at what you paste before you actually submit. Number 2, you can't actually type inside this box. So if you try to type, nothing will happen. So you can't do that. So when you do the paste option, go to your Word or wherever it is, highlight everything. You can use Control-A to highlight, or just use your mouse, click and drag, Control-A to highlight, Control-C to copy, and then go back to the box, and then Control-V to paste. Boom! And then once you're ready, the submit button will open up. Then you can hit submit. Boom, submit, and we are ready to go. Question 2 opens up, and then in a little bit. You forgot your AP. I did. I forgot my AP ID and my initials. You should definitely write down your AP ID and your initials at the top. However, I looked at the College Board president's tweet yesterday. Apparently, if you forget, it is actually okay. But for good practice, you should definitely put your ID and your initials at the top. But if you forget, don't worry. All right, so my question 2, forget. Question 2 will open up. So do the same thing, copy pasta, and then submit. When you're uploading images, don't hit the submit button after you upload your first image, right? The submit button means actually go and move on to the next question. When you move on to the second question, you can't go back to the first question, just like your Canvas stuff, right? So when you're when you're uploading photos, take a look at the guidelines. When you're uploading photos, here we go. Write your API ID, your initials, and page number at the top of each page. You can only attach one photo at a time. Do not hit submit until you've attached all of your photos. Okay, so you keep attaching until you're done with all of them, and then you hit submit. So please, don't be that one kid who like uploads one picture and then hits submit thinking that submit means upload. It doesn't. Submit means go to the next question. Here's some other guidelines. So again, PNG, JPEG, JPG all work. The minimum size is 10 kilobytes, and the maximum is 25. Definitely use Bonte's. What did Bonte say again? Suggestion. Oh yeah, if you have an iPhone, put your camera setting on compression. On Android, if you have Android, just check your settings, check the megapixels. You can actually change the megapixels. Just go to your lowest megapixel setting. You don't need a high-res megapixel. This is not an art contest or photo contest. The photo contest is canceled for APC. But as long as it's visible, right? So again, if you are taking pictures, make sure your windows are open and you can get light into your room so it's nice and bright. And make sure it's look at these pictures. Look how the camera is right above and there's light flooding in from all directions so you can actually see everything. Consider using a pen because it comes out darker, or if you use a pencil, make sure you write really vigorously with force. There we go. So that it comes out nicely on the picture. All right. Or just use the copy paste method that I showed you. I think it's safer. All right. So over the next 2 days, you should definitely practice. Go to AP2020 examdemo.collegeboard.org. Practice. Use it. See which one works for you the best. Is it using your phone or is it the copy paste method? Whatever it is, choose which one. Just be prepared. Don't let Thursday be the first time using this platform and then you run into issues, right? All right. So that's that for the platform. Let's go ahead and go back. Maybe we should. I don't really want to do this, but we might as well talk about this. I'll just talk about a few things. Let's see. So let's start with our first FRQ. This is quiz 4 review. FRQ 1. There were multiple FRQs, so you may have gotten this one or you may not. So stay tuned. So FRQ number 1 was the classic ladder leaning against a wall. Ladder leaning against a wall. So here's our ladder leaning against the wall, like so. And so things that you should know about this type of question. Number 1, the mass of the object, or the gravitational force, is from the center of mass, so straight from the middle. Okay. Everywhere we have contacts, like the ground, will provide a normal force. We'll call this Fn1. Now, of course, on your quiz it was labeled like force wall and force ground or something like that. But anyway, here's Fn1, and when you're touching the wall also pushes you. Fn2. Normal force, remember, is always 90 degrees. 90 degrees to the surface. The normal force, even though you're leaning at an angle, the normal force is 90 degrees to the surface. Now if there's friction and stuff, you can get friction, sideways, or sorry, friction that would be parallel to the surface, but normal force is always perpendicular. In this problem, the wall, a ladder is set against a wall. The angle is 30 degrees. Okay, the wall is very smooth, so there's no friction on the wall, but there is friction on the floor. And so you can see how the ladder would slide downwards and towards the right. So friction is going to try to prevent that, keeping me up against the wall. So there's my friction force. If I have enough friction, enough static friction, I'll stay up against the wall. If I don't, like in this problem, we will slide out. So in this problem, we don't have enough friction, and so on. Describe the forces. So we did. Explain why Fg is greater than the gravitational force is greater than NF. What is NF? The floor. Oh, okay. So for these types of problems, set up your torque equations, and then you can compare the forces, etc. And in order to stay in static equilibrium, you would you set everything equal to 0. But if you know if something is actually accelerating downwards and to the right, then your sigma equation at the end does not equal 0. It would equal ma, or in this case, alpha or something. So if it's downwards to the right, it's somewhere this way, or it's actually rotating as it's, you can say that it's rotating as it's going downwards or something like that. Okay, so ultimately use Newton's second law to figure out which force is greater and so on. So the fact that it moves downwards to the right and there's a net sigma fx, and sigma fx is not equal to 0, it's equal to some sort of max. This tells you that there's a net acceleration to the right. Therefore, whatever forces I have pointing to the right must be greater. So in the x-axis, we have Fn, well, let's call this Fn2. Fn2 must be greater than Ff, right? Based on the fact that we are accelerating to the right. Again, in a static equilibrium case, sigma fx would equal 0, and the two forces in the x-axis would cancel each other out. But the fact that it is sliding away means that the rightward force is winning. And so this is the idea that you would use to answer the rest of the question, right? So the fact that gravity is the fact that it is moving downwards, we know that in the y-axis it's not 0, it's some sort of m times ay, and we know the net acceleration is downwards. Therefore whatever is downwards must be greater than whatever is upwards. So therefore the gravitational force must be stronger than the normal force from the ground. Otherwise the center of mass would be in equilibrium or going upwards. All right, so that was the trick behind this question, is to use sigma equations, and then the right side of the sigma equation is not 0 because we're not in static equilibrium, and based on that non-zero value you have to figure out which force is greater. Let us move on to the next FRQ. The next FRQ is rolling up hills. Let's see. We have an object like this rectangle thingy. What is this thingy? A cart. Oh, we have a cart of mass m, and then in the other picture we have a wheel also of mass m. They're both moving at VO, like so. So this one is mass m, a cart of mass m that slides across the surface with negligible friction, so no friction, with initial speed v, VO, encounters an incline with an angle of theta. So we have an angle of theta here. Same thing with the wheel, except the surface is different for the wheel, because the wheel also of mass m and radius r, the wheel actually rolls without slipping. Remember, in order to roll without slipping, you have to have static friction, otherwise it would slip. So this one, the cart, is no friction. This one is rolling without slipping. Yes, there's friction, but the friction is not actually slowing us down. It's what's causing the torque and making us roll in the first place. Okay. So consider the forces acting on the wheel. Is the friction force acting on the wheel static or kinetic? All right. If we're going to do rolling without slipping, it has to be static. FFS. Okay, now for the actual FBD. When you go up the hill or down the hill, it doesn't matter which way actually, what does the FBD look like? Well, of course, mg points straight downwards from the center of mass. The normal force is from the point of contact, as we said yesterday. Now, when you're going up the hill or down the hill, the friction force is up the hill. Whoa. And it actually, in the next part, it actually tells you, now you have to explain why the force on the wheel, the friction force on the wheel points up the incline instead of down the incline. So why is the force up, as you're going upwards, the friction force is upwards? How does that make sense? Well, the way to think about this is to actually take away the friction. Imagine having your wheel here. Well, without friction, it would just slide. It would just slide. And so friction is going to cause some sort of torque, slowing you down. Now, the gravitational force, as you go upwards, whatever height you go up to, will take away the kinetic energy of the system. Now, there is also in AP Physics C, you'll learn about rolling friction, but we don't really consider rolling friction in AP Physics 1. Rolling friction is the one that will be against the motion if there is rolling friction. So if the thing is going up the ramp, the rolling friction will be down the ramp. But the static friction force is actually up the ramp here. So this is what prevents it from slipping. Otherwise, if you have it down the hill, notice how the direction of the force will be will give you a torque that goes clockwise, and this clockwise turn will actually force you to go up the hill even more, and we don't want that. And so we want our force to be in a direction such that the torque will be the other way. Okay, and therefore it'll be like the wheel is rotating at a slower rate, which means it is slowing down. All right, both the cart and the wheel will eventually come momentarily at rest at some point. However, the wheel takes longer time and travels a longer distance. So the question is, why does the wheel travel further up the hill than the cart? Okay, so when you deal with height, think about energy. Here we had kinetic energy, which is equal to 1/2 mv squared. I should say VO squared. And that 1/2 mv squared turned completely into peg-mega at the end. Okay, well, what about for the wheel? Well, the wheel, which is also moving at VO, has two types. It has two types of kinetic energy, Kekarot, which means it has both 1/2 mv squared, mvo squared from the center of mass, plus it has rotational energy. So the wheel is actually cheating. So if the center of mass of the wheel is traveling at the same rate as the cart, it actually has more energy than the cart, because it has 1/2 I omega squared. And therefore you have this extra bit of energy that eventually gets converted into peg-mega. Therefore your height will be more for the wheel. Explain why this happens in terms of forces. So we did that in terms of energy. In terms of forces, how do we do this in terms of forces? Well, whoa, what happened to my screen? Oh, here it is. Okay. Okay. In terms of forces, you can see that for the sliding cart, we just have normal force and mg, and it's only the mg sine theta slowing you down. So you can say that mg sine theta is in the opposite direction to the motion of the cart. Therefore, that is the force that is slowing me down, right? Here you actually have two forces. Whoa, this is weird. You have mg sine theta and you have ff going up. And so there's this tug of war. Of course, mg sine theta is going to win out because we know that it eventually comes to a stop. But there's this tug of war, so the impact is actually less for some reason, right? So therefore, because the total x component, remember, on the ramp, your x-axis is along the ramp itself, and the y-axis is perpendicular to the ramp. So the sum of all forces in the x-axis is actually less in comparison to the sum of all forces in the cart diagram. So I suppose due to forces, it also comes to rest at a. It takes longer to come to a rest because there's the less net force on the wheel, if you will. All right, so that's one way to look at it. Okay. Let's see. The last FRQ. Where is it? Last FRQ had a bar that can spin around an axle. So here's my axle, and this bar can spin around, kind of like a physical pendulum. Consider taking AP Physics C to learn more about physical pendulums. This bar has a certain length and mass. A bar of length L and mass m is constructed so that it is not uniform density. Whoa, it's not uniform density. What does that mean to us? Well, normally when it's uniformly dense, the center of mass is directly in the geometric center. They say that this is not uniformly dense, meaning it's heavier at the bottom. So therefore, the center of mass is shifted downwards some x amount. So the center of mass is here. So the whole thing is L. I should use curly L. Whatever. Here you go. The whole thing is L, and from the pivot point, x distance away from the pivot point is your center of mass, not directly at the middle. Okay. But x is given, so we can use it. The material are painted over so that it is not possible to determine visually which end is made of which metal. Blake must determine the rotational inertia of the bar if it is pivoted about the less dense end. Okay. All right, so part one, the center of mass is located a distance x from the less dense end. Explain how Blake can determine the location of the center of mass to determine which end. So similar to how I did the center of mass demonstration, remember how I had a meter stick with some masses attached to it at different points? Okay, so we don't know where the center of mass is. What you can do is put your fingers. So you put your finger here from your left hand, and you put your finger here, your index finger here on the right hand. And what you do is you slide your two fingers towards each other slowly, and you'll see that as you approach it, eventually the two fingers will meet somewhere at the center of mass. Okay. And what we're doing is actually using torque to our advantage. As the fingers slide against each other, the normal force on each finger is different. So when the normal force increases, the friction force increases on that side, which stops the finger from moving, and then the other finger starts moving, and so the magnitude of the normal force keeps swapping back and forth between each finger. So this is left index finger. This is the right index finger. So you can do it that way. What are other ways? Well, you have to balance it, find the balance. I don't know. I guess you can be creative. If you actually, technically, did you know? If you just take the bar and throw it upwards, assuming the bar is light enough for you to do that. Kind of like flicking a pencil. So if you can just hold your pencil by the end, so use your pincer grip here, grip right here at the top. It's kind of like holding your pencil from the top. And if you just throw your pencil upwards, you'll see that the pencil will rotate around its center of mass. Remember, the center of mass has the lowest moment of inertia, so therefore naturally it will spin around the axis that has the lowest moment of inertia, and the axis through that the moment of inertia will go through the center of mass. Right? ICM is always less than any other axis. Okay, so those are other ways. Throw the bar and let it spin. It'll spin around the center of mass. All right. B, once the less dense end and the x distance are determined, the bar is fixed to a horizontal axle. Okay. Write a procedure that Blake could follow to make measurements that could be used to calculate the rotational inertia of the bar about this axis, assuming friction is negligible. Blah, blah, blah. Okay, so basically we need to figure out what I is. We can use, let's see. Let's have the bar be sideways. It's kind of like the problem we did, I guess, yesterday, right? So have the bar sideways and let it go down. Whoa. Okay, so we're going to measure. What do we measure? Well, we can say that whoa is 0. Okay, we don't know what whoa final, omega final is. Alpha, displacement. We can do displacement. Oh, it's not displacement, it's theta. Sorry. Theta would be pi over 2, 90 degrees worth. So theta would be pi over 2. So we're going to let this go downwards all the way to here. And then we'll go ahead and measure the time, how long it takes to go down to the bottom. And then using, your watt, you can figure out what alpha is, right? How do we find our moment of inertia? Well, now we use our torque equation. So sigma tau should be equal to the net force, net torque on the system. The net torque is the force times the distance. Now, I see. If I do it this way, we're assuming that the force is always constant, right? This is why we can't do it this way. Whoops, scratch that. Because the force is not constant. The other thing we can do is energy, I suppose. So energy it is. So no alpha. Let's see. Kinetic energy or rotational kinetic energy is Ke rot would be 1/2 I omega squared. So we need the final omega. So instead of A, we're going to solve for final omega instead. And we can say that the initial energy, so Ke final, mechanical energy final, we have to write our conservation law first. Mechanical energy final must equal mechanical energy initial. So the peg mega at the start, or the change in peg mega, is going to equal my kinetic energy. Okay, how much did the kinetic energy change, peg mega change? Well, that's going to be based on, like I said yesterday, based on the change in the center of mass. The center of mass is some x distance away. So when it's vertical like this, the center of mass is now down here, x distance away. So it started up here, and it's basically going to fall x distance. So your height is x. So mgx must equal 1/2 I omega squared. So we'll use watt to find omega, and then mgx equals 1/2 I omega squared. We can't use torque, even though I tried. We can't use torque, so we cannot say that. We can't say mgx is equal to I alpha, because the force is not constant. Remember, technically it has to be the dot product, it would be mg. Initially it's true, but not as it rotates. So we would have to say technically mg, if we were using torque, mgx sine of theta is equal to I alpha. And the problem is that theta is changing as a function of time as it rotates. All right, so that is the third FRQ. There were some MC questions. Let's see. There's a ball question, a dumbbell question, where you had mass M and a bigger dumbbell, mass 2M. And so why doesn't it rotate is the question. Okay. So what is true is that there are different forces affecting each mass. Okay. This mass is being pulled down with a force of M times G. Okay. This mass is being pulled down with a force of 2m times g. So technically the 2m is being pulled down with a greater force. However, the center of mass is shifted towards the 2m mass, right? The pivot of the system, the axis of rotation, would be closer towards the 2m. Remember, if it's twice as massive, it's going to be half the distance. Or in other words, it's a 2/3, 1/3 split. So if the whole thing was L, then this distance would be 1/3 L, and this distance would be 2/3 L. But anyway, what you have to know is that the center of mass would be closer to the 2m mass. So the 2m mass has a greater force, but a smaller r, whereas the single m mass has a smaller force, but a greater r. And therefore the torques on each side, the torque that is counterclockwise and the torque that is clockwise, will match each other, and therefore it doesn't spin. So when you drop this dumbbell, even though the masses are different, it'll just go straight down without spinning. I guess that was the most missed question. Actually, the other most missed question was this graph question with kinematics. Oh no, kinematics question, that should be a freebie. So in this kinematics question, you have two graphs. One for object 1. Object 1 goes diagonally this way. And object 2 goes diagonally this way. Okay, it doesn't tell you when they end, but it shows that this is capital T. T amount of time has passed. And so pink is all the way up here, purple is over here. Ooh. Whoopsie daisy. All right, let's see. I drew it kind of wrong. There we go. They look like they're parallel. Okay. And what we need to note is that pink starts off. Oh gosh, that doesn't look good at all. Let's go and draw purple slightly downwards. Pink starts off where purple hits T. All right, so there we have it. And this object 1 starts at 0 velocity, and object 2 starts from VA to VB. So this is VA, velocity A, and all the way up here, is VB. All right, so let's see. Two objects are at two objects are to fall straight downward under the influence of gravity with an acceleration of g. Object 1 is released from rest, and object 2 is thrown downward with somewhat greater height and with an initial velocity va. So basically, object 1, which is purple, okay, starts from 0 and then it accelerates at g. Object 2 is thrown downward, so it starts with va and then it also accelerates at g. That's why the slopes are the same, because they have the same acceleration. Right. And then let's see, graphs of their motion are shown above. The second object catches up with the first object at time t. So once time t is finished, the second object catches up with the first object. Remember, the second object was thrown later, right? Was it? Two objects fall straight downward under the influence of gravity. Object 1 is released from rest, and object 2 is thrown downward from somewhat a greater height with an initial velocity v. Oh no, they're both at the same time. It's just that it's traveling from a greater distance. So we don't know. So let's see. So imagine here's a window in the middle of a building, and your boss, who's always at the top of the building, and your boss throws object 2 down with VA, and you let go of your object with 0 meters per second, or at free fall, basically. Okay, so after t time, after t amount of time, of course, your object is just falling straight down. After t amount of time, it's going to travel d1 distance. But in that same amount of time, your boss, who threw the rock downwards, will travel a greater distance, like so. Okay. So the second object catches up with the first object at time t. Which of the following expressions correctly describes the initial difference in heights? So basically, how can I get d1, the difference in height? How can I get d1, or sorry, d2 minus d1? This is the height that I'm looking for, right? We can get displacement from area under the curve. Okay, so the pink is the area for the pink object 2, and so the area for object 2, the pink, gives you displacement for 2. And if I did purple, the area under the curve for purple is the displacement for object 1. And we can subtract the two areas, d2 minus d1. This will give us the height. So subtract the two areas. Right? The area is the triangle, so we're going to subtract a triangle from the trapezoid thing, the pink trapezoid. All right, now, based on the fact that we are accelerating for the same amount of time, okay, the gain in speed is actually the same. Okay, meaning if you accelerate at g, every second you are gaining 9.8 meters per second. So this is 9.8 meters per second per second. Okay, so if t was just 1 second, that means if I started from 0 meters per second for object 1, that means after 1 second, object 1 is moving at 9.8 meters per second. Okay, and it shows that object 2 was released at the same rate. So whatever final velocity that object 1 hits is the initial speed of the object 2. And that means whatever that is, object 2, which traveled for the same amount of time, will also gain the same amount of velocity. And even though object 2 starts from a higher velocity, the amount that it gains in speed is the same as the amount gained by object 1, meaning whatever this height of this triangle is must be the same for this height of the triangle. Okay, meaning these two rectangles that we have that you can see are actually the same height. So we're just taking off a triangle from our rectangle. Oh, sorry, from our trapezoid. So I have a trapezoid that looks like this. And then if I subtract the triangle, oops, figure was not drawn to scale. Let's try again. I have to make sure that these two heights here on the side are the same. There we go. So if I take away this triangle, what do I have? I have a rectangle. And this rectangle is the leftover H. All right. That's all we have time for. This is the end of our review series. Tomorrow there's no stream, so Thursday you take your test. What should you do? You should definitely review your notes. The College Board has released FRQs. Now the FRQs will be slightly different, more experimental based. So I would go through the release. Look at released FRQ. At least look at the last couple of years, maybe like 2016 through 2018 or something like that, and focus on the experimental based questions. Focus on experiment questions or lab questions, lab design questions. They're not always an experiment, but they could be a lab that's already designed and you have to think about how to modify it, all sorts of weird stuff. Lab questions. And paragraph questions. So some of the questions will say, in a paragraph length response, blah, 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 blah. So look at those types of questions. The calculations ones you can kind of skip. The more time you have to invest, go ahead and do more. As I'm sure there are more release questions. How do you get to this? You can literally Google it. So just type, what do you type? Let's see, AP Physics 1 released FRQ. This will take you to the College Board website where all the FRQ questions are. There's also scoring guidelines. There's also sample student responses that you can take a look at. So I would definitely do this as preparation. And then make sure you sleep. Now it is an afternoon test, right? So you guys technically have some time. If you're in chemistry, I think chemistry is in the morning, and then you take your physics. Yikes, good luck. Just blaze through the chemistries and then start focusing on physics. All right, well, best of luck. Thanks for tuning in. I'll see you next time.